Have you ever visited Trinidad's tallest waterfall? It's quite a sight. While you're on the ground and looking up at this marvel, there are some adventurous people who've made it all the way up and can tell you what it's like to look down at the base of this same waterfall. Whether elevation or depression, both are interesting perspectives of one of our well-known natural features. Stick around to find the angle you'd most likely be taking in this sight from. This is Mastering CSEC Mathematics Bite-Sized. Whether you're a nature enthusiast, an aspiring aircraft pilot, or even considering being an architect, there's little geometry in your everyday activities which we often overlook. Angles form between intersecting lines, and there are two specific angles we investigate in real-life scenarios, called angles of elevation and depression. Let's see how these angles are formed and how we can distinguish them. Mary sets out to visit the Maracas waterfall. On arrival, her first action is to look up at the top of the cliff. The angle of elevation forms between the horizontal and her line of sight. In mathematics problems, this horizontal in angles of elevation is simply considered as ground level. The line of sight is the imaginary line which moves upward from the horizontal towards the point at the top of the cliff. Can you identify where an angle is formed? The angle of elevation forms between the horizontal and the line of sight. Now, let's see. Mary is standing some distance away from the cliff. We can create a triangle using the top of the cliff, the base of the cliff, and the point where Mary is standing. This triangle creates a 2D representation of the scenario involving the height of the cliff, the distance Mary is standing from the cliff, and her line of sight to the top of the cliff. This is where trigonometric ratios can help us out depending on the information we have and would like to find. Suppose Mary is standing at a distance of 30 feet from the base of the cliff. What is the angle of elevation Mary has to tilt her head to see the top of the cliff? Do you know the height of our tallest waterfall? It stands at 91.5 meters high. That's equal to 300 feet, which is roughly equivalent to stacking up 12 identical two-story houses. Now, if we want to determine the angle of elevation, let's make a diagram with all this information. We have the height of the cliff and the distance Mary is standing from the base of the cliff. This is the angle of elevation, which we don't know yet. We can label it with a variable. Let's use x. If you usually confuse the sides of the triangle for trig ratios, try looking at it like this, where Mary is standing, that's our perspective. The cliff is opposite to Mary, so that side of the triangle is called the opposite side because it's opposite to angle x. The distance from Mary to the base of the cliff is the side that's practically next to Mary, and because it's next to the angle x, we call it the adjacent side. Now, we are assuming that a right angle triangle forms here, where a right angle forms between the ground level and the waterfall cliff. This means the other side of the triangle, our line of sight, is the hypotenuse of the triangle. Which trig ratio uses the sides opposites and adjacents? That's the tangent ratio, so we write tan x is equal to opposite over adjacent. How do we apply this information? The opposite side of the triangle is the cliff's height, so substitute the cliff's height of 300 feet. Next, she is standing 30 feet away from the base of the cliff, so we replace the adjacent side with this distance. We simplify the ratio and this gives us 10. To find the angle, we use the inverse trig function of tan inverse or arctan. We enter the ratio to obtain the magnitude of the angle. This gives us an angle of elevation of 84.3 degrees. That's an uncomfortable angle to maintain for a long time, so take a quick glance up and enjoy a cool, refreshing shower beneath the falls. Now, I'm sure if you're someone who uses TikTok often, you've at least stumbled across some hikers who have ventured to the top of the cliff out of curiosity. What is at the top of the falls? Well, I won't spoil it. I'll let your curiosity help you find the answer. But what if we were at the top of the falls instead and took a chance to look down below? We'd be forming an angle of depression between the horizontal and line of sight. In this scenario, though, the horizontal is assumed to be our natural line of sight without tilting our heads upward or downward. Our adjusted line of sight forms an angle of depression with the horizontal. Mark is looking down from the top of the cliff. He is looking at a flag some distance on the ground from the cliff. If Mark's adjusted line of sight forms a 60-degree angle of depression, how far away is the flag from the base of the cliff? We'll create a 2D representation for the scenario and fill in the necessary information. This time we know the angle of depression and the height of the cliff. Now pay close attention to this, as it will prevent you from getting depressed while working out math problems like these. The angle of depression forms outside of the triangle. We can use a couple of approaches here to get an angle within our triangle to solve the problem. One option, complementary angles sum to 90 degrees, and the use of this is to find the angle at the top of the triangle. 90 minus the angle of depression leaves us with 20 degrees. Now option 2, our angle of depression forms an alternate angle with this angle where the flag is. Notice the Z shape. That means this is a 60-degree angle forming here. Both options will give the same solution, but pay attention to the working as it will differ slightly in each case. Let's work with option number 1. The distance we want to find is the side at the base of the triangle, which is opposite to the 30-degree angle. The cliff is next to the 30-degree angle, which is our adjacent side. This means we'll use the tan ratio. Tan 30 is equal to opposite over adjacent. Since we want to find the opposite side, let's first substitute the adjacent side, 300 feet. Now we will rearrange the formula and make the opposite side the subject of the formula, and then evaluate our answer. Multiplying both sides by 300 gives us 300 times tan 30 is equal to the opposite side. Evaluating this, we're using the tan function to find the trig value of the angle, and then multiply that by 300. Tan 30 is 0.5773. Multiplying this by 300 will give us 173.2 feet. Whenever next you're looking up at the clouds in the sky or looking down to make sure your shoelaces are tied, just remember there's a little math that goes into those everyday motions. If you found this lesson helpful, informative, or even enjoyable, let us know by leaving us a like or a comment. Don't forget, sharing is caring, so help a friend by sharing this video, and if you're interested in our upcoming videos, be sure to stick around by following this account for more bite-sized lessons. We're also beginning registration for our September class intake for students in Forms 3 to 5 for online tutoring. No hassle, no traveling to and from locations, no large intimidating class settings. Just you, your fellow peers, and your tutor in the comfort of your home. We use online platforms for lesson support so you can get access to your resources, and your sessions are designed to be interactive and engaging so you actively participate throughout your sessions. WhatsApp us for more information.